So the second topic I would like to discuss is asymptotes. This should be just a review of things that you did last year, but you might not quite remember it. So a vertical asymptote is going to occur in a rational function, meaning that it's a fraction, and it will occur at an x value that gives a zero denominator. And there is one exception. I'm going to talk about that in just a minute. So vertical asymptotes occur at x values that give a zero denominator. And I'm actually going to put a little star next to that. The star is where I'm going to be talking about the exception in just a few minutes. Okay, so let's do an example. Let's say we have f of x is equal to 4 over x minus 3. If you'd like, you're welcome to graph this. I highly recommend that, actually, so that you can check your work. There is a vertical asymptote here at x equals 3. You can find that by setting your denominator equal to 0. You've probably always learned, maybe ever since middle school, that you are not allowed to have a 0 in the denominator. The reason for that is because you will have an asymptote there. So let's talk a little bit about horizontal asymptotes, and I'm going to talk about that exception to the rule. So for horizontal asymptotes, there's a few rules. Unfortunately, you do need to know these rules. There's really no way around it. So hopefully you kind of remember them from last year, but if not, we'll go over them right now. Before anything else, I'm going to just show you some abbreviations I'm going to use. So I'm going to call n the degree of the numerator. By degree, by the way, I mean the highest exponent. D, the degree of the denominator. A is going to be the leading coefficient of the numerator, and B is going to be the leading coefficient of the denominator. So let's go through the rules. There's 3 of them. So first of all, if the degree of your numerator is less than the degree of the denominator, the horizontal asymptote is going to be at y equals 0. So actually, an example of that, if you went ahead and graphed that initial one, f of x equals 4 over x minus 3, the degree of the numerator is 0. The degree of the denominator is 1. This one has a horizontal asymptote at y equals 0. So the next thing is if the degree of the numerator is greater than the degree of the denominator. In that case, there's going to be no horizontal asymptote. This one doesn't really come up that often in this class. Oftentimes, these actually will have a slant asymptote, which we're not even going to worry about right now. But if you have something like this, that one will not have a horizontal asymptote. So our final case is if the degree of the numerator is equal to the degree of the denominator, your horizontal asymptote is going to be at the leading coefficient, of the numerator over the leading coefficient of the denominator. So I'll give you an example of that. Let's say you have 4 minus 3x squared over 5x squared plus 2x plus 1. Your horizontal asymptotes, you're just going to look at the highest terms and actually look at those coefficients. It's going to be at -3/5. So before we do some examples, I'd like to talk about our special case. Okay, so our special case is if you have a rational function, you factor everything out, and you find that something cancels out, then that value will not have an asymptote. It will actually have a hole. So I'll give you an example. So let's say you have a function that looks like this. You're going to find that that x minus 1 is going to cancel out. That means that there is a hole at x equals 1. You get that by setting x minus 1 equals to 0. You also sometimes might want to find the y value. It would actually occur at 1. In order to find the y value, you would have to substitute the 1 into the equation that you get after you cancel that out. So I substituted into x plus 2 over 2x plus 3. So you would find that there was a hole at 1 3/5. So the other thing in this equation is that you will have a vertical asymptote when your denominator equals 0, which is going to give you a vertical asymptote at -3/2. Your horizontal asymptote is going to be based on the leading coefficient, so it actually will be 1 over 2. By the way, I didn't mention this previously, but it should be y equals because it's a straight horizontal line. So I'm going to go ahead and give you some examples to do on your own right now. So here's 2 examples for you. Please pause the video and do them on your own. Okay, so for number 1, you should find that there is a vertical asymptote at x equals 1. Actually, if you find that by solving the equation x cubed minus 1 equals 0, the only possible thing that you can get for that is x equals 1. There's no negative in that one because it's a cube, not a squared. Your horizontal asymptote is going to be at y equals 0. We know that because the degree of the denominator, which is 3, is greater than the degree of the numerator, which is 2. I recommend that you graph this either on your graphing calculator or using Desmos. Then you can just take a look at it to verify. I do recommend that you do that with all of your, anytime you do asymptotes or anything related to a graph. For number 2, you will find that if you try to find a vertical asymptote, hopefully you did not get anything. You actually will get an imaginary number if you try to figure it out. So there are none. For your horizontal asymptote, you'll notice the degree of the numerator and degree of the denominator are both 2. They're equal. So your horizontal asymptote is going to be at y equals 3/2. Again, I do recommend that you graph this to double check your answers.